Okay, so where the last video left off, we were talking about this equation, which is the equation for calculating the electrostatic force of attraction or repulsion between two charged objects. This equation is actually called Coulomb's law. It's one version of Coulomb's law, really. Coulomb's law. Okay? And the K is the constant, called an electrostatic constant. We talked about the fact that it parallels the Fg equals gmm over r squared exactly, right? Instead of the two masses, it's the two charges. R squared is the distance between them squared. Fg was the constant in the Fg equation. K is the constant here. It's equal to 9 times 10 to the 9th Newton meters squared per Coulomb squared. Remember, G was Newton meters squared per kilogram squared. This is actually a slightly rounded version. It's really 8.988, but in this course we use 9 times 10 to the 9th. Okay, and FQ, then Fg was the gravitational force of attraction, but FQ is going to be the electrostatic force of attraction or repulsion. Okay, so it's the electrostatic force of attraction or repulsion. Now, whether it's attraction or repulsion depends on the nature of the charges that you have. So think about the math, right? So it's K Q1 Q2 over R squared. So if the two Q's are both positive, then FQ is going to be positive. But what type of force will that be? If the two Q's are both positive, it'll be a repelling force because two positives don't like each other. If they're both negative, if two Q's are both negative, then, oops, sorry, I'm tipping the thing and it's making it blurry. There we go. Then the FQ will be positive again, right? Because a negative times a negative will be a positive, and we know that like charges repel, so it will also be a repelling force. If one Q is positive and one negative, then FQ will be negative. Oops, let me put it down here because FQ will be negative. And if FQ is, and if they're one positive and one negative, that means they like each other. This is an attracting force. So whenever it says that attractive force, then you need to know that FQ is going to be negative. Or whenever you get a negative on a force, it means it's attraction. And if it ever works out to be a positive, it means it's repelling. Now, most people will say that's opposite of what it should be because they think positive should be attracting. Now, the way you can remember this is to think about me. Because if you're a nun with a vow of celibacy like I am, then a force of attraction is definitely a negative thing. A force of repulsion, definitely a positive thing. It's also true for those of you that are in a committed relationship with someone else. If you feel a force of attraction to a totally different person, definitely a negative thing. Okay, so force of attraction is a negative thing. Okay, and so you need to remember that when you're doing the math here, because if you're finding a force and it works out to be negative, then you're going to have to say, oh, a negative means attraction. Or if you're told it's an attractive force and you're trying to figure out the Q or the R, you're going to need to put the force in as a negative, or else you're going to get a negative R or something crazy. Okay, so let's try a couple of examples. Oh, one more thing before we do this example. So I told you that the unit of force is a coulomb. But when we're talking about charged particles, a coulomb is huge. So you will not often see a charge that's 1 coulomb. It's kind of like if you're measuring the thickness of thickness of people's hair, like just the individual strands of hair, and you're using a meter stick. It would be way too big of a unit of measure. So what we tend to use is a mu c, which of course you remember from grade 11 physics that the mu is micro, and it's equal to 1 times 10 to the negative 6 coulombs. Okay, so this is a microcoulomb. So you'll see that a lot. Now and again you might see nano, which would be to the negative 9, but most often it'll be micro. So let's say that Q1 is, I don't know, 2 times 10 to the negative 6 coulombs. Q2, I should have written it as, sorry, I'm trying to come up with a number here, 3 microcoulombs, which is 3 times 10 to the negative 6. And let's make our life easy for right now. Let's say R is 2 meters. Okay, and so you do FQ is equal to KQQ over R squared. FQ is equal to 9 times 10 to the 9th Newton meters squared per coulomb squared. Why do I always do it too far to the edge? Times 2 times 10 to the negative 6 coulombs times 3 times 10 to the negative 6 coulombs. And this is all divided by 2 meters squared. So this 2 meters is that's gonna be 27 divided by 2, 13.5. And then where is the decimal? Negative 6, negative 12, negative 3, 13.5 to the negative 3. So I think it's going to be 1.35 to the negative 2 newtons. But I just made those numbers up and I'm doing it in my head. So there is no guarantee. Should I check it? I suppose 9 to the 9th times 2 to the 6 negative times 3 to the 6 negative divided by 4. Yes. That's the same thing as 0.013. Okay, so that's example 1. But let's suppose in our second example, which I think if you downloaded the pages of notes, I think I gave it to you. In the second example, it says that Q1 is 18 microcoulombs, and it says there's a force of attraction, FQ, of 0.86 newtons on a Q2, which is 12 microcoulombs. And so it says a force of attraction. So you have to put a negative here. Remember, forces of attraction, negative thing. And part A of the question says, what is the nature of the second charge? So it told us the first one was positive 18 microcoulombs, and it says the magnitude of the second one is 12 microcoulombs, but it has to be force of attraction. It has to be, if they're attracting, a negative, right? Okay, so I don't have to tell you that. And then the question wants to know what's the R. And so you would do FQ is equal to KQQ over R squared. So R squared is equal to KQQ over FQ. So 9 to the 9th Newton meters squared per coulomb squared. 18 to the negative 6. Negative 12 to the negative 6. And then it gets divided by negative 0.86 newtons. And remember, the number you're going to get here is R squared. You should get 2.26. This one I didn't make up. 2.2605 meters squared. Take the square root, 1.5035 meters. So if you had downloaded this sheet, it's on the back of that one, okay, that question. All right, so tonight's work is just going to be simple ones like this with this equation. We'll make them a bit more complicated tomorrow. So tonight's questions are on page 638, numbers 1 to 5, please.